To detect electrical activity in the heart, we need to apply electrodes on certain parts of the body in order to sense the movement of electrical current. The detection of electrical flow is now converted into waveforms, which we could watch in either a monitor or inscribed in an ECG paper. Two electrodes, a positive electrode and a negative electrode. The principle is this, that if the electrical current moves towards a positive electrode, then the result will be a positive waveform or an upright waveform. If the flow of electricity is going to go towards the negative electrode, such as this, the corresponding waveform that will result will be a negative deflection. So this is how inscriptions are made in the electrocardiogram and why it is sometimes that it is positively deflected or they're negatively deflected. In essence, if current flows towards the positive pole, it produces a positive deflection, such as what you see over on this area. And if it is going to move towards a negative electrode, it's going to produce a negative deflection, as illustrated in this particular waveform. And if it is going away from both poles, it will produce a biphasic deflection. So let's take an instance or a situation wherein we're going to put a positive electrode over in this area and a negative electrode over on the right arm. Now, we all know that the heart is pointed or has an orientation that points it morally towards the left side, and thus the net direction of electrical flow is going to be from right to left. Inasmuch as the waveform is going to go towards the positive electrode, this view or this lead will therefore show a positively deflected waveform. This illustration here is what is known as lead 2. Now let's suppose now that we put the negative electrode right over here and the positive electrode right over here. And we said that the net flow of electrical current is going to be from right to left because the heart is oriented towards the left. What then will be the inscription on the electrocardiogram? Will it be a positively deflected waveform or a negatively deflected waveform? The answer to this question is inasmuch as the direction of flow of the electrical current is towards the negative electrode, the result will be a negative deflection. The different views of the heart, named as leads, is accomplished by attaching electrodes to several parts of the body, as illustrated over here. And each of these views will have a distinct characteristic of the waveform, depending on whether or not the positive electrode is located towards the movement of the electrical flow or away from the movement of electrical flow.